Today, we'll be going through setting up a virtual machine or notebook instance on Google Cloud Platform. We'll also be going through how to run that instance from a custom container in your project's artifact registry. And finally, how to run Jupyter Lab from your instance and clone in a public GitHub repository. When you sign into your Google Cloud account, you will arrive at the console welcome page. Make sure you're in the appropriate project and then navigate to the left-hand side hamburger icon and click on it. Go to Vertex AI and then Workbench. This will bring you to the Workbench window. Make sure you have the instances and instance view clicked. You may not see any old instance names or historical instances if your project is new. However, we are going to create a new instance. When you click on Create New, this will bring up a pop-up window on the right where we'll see some basic options for creating our new instance. We're going to click on Advanced Options to look at more detail of some of these parameters that we can set up when we create our instance. First, provide an instance name for your virtual machine. The instance name must conform to the format outlined below. You can then select your region and zone, and also the workbench type, which we've already chosen as instance. Then click Continue or Navigate on the left-hand side. Next, we'll go to Environment. Most of the default options for these various options on the left should suffice. However, I also want to show you how to use a custom container to run your instance from when setting up your instance. To do this, click Use Custom Container, and then as long as there is an image in your artifact registry in the project you're using, you should be able to click Select, navigate to the appropriate zone, and then select the image that you want to run your instance from. And this will set up automatically upon creation of the instance. I'm going to uncheck this for now, since the instance I'll be creating won't be running from a custom container. Next, we'll go to machine type, and this is an important thing to consider when setting up your instance to understand what type of and the amount of compute that you'll need for the processes that you'll be running in your module. A suggestion should be provided in the module README when setting up your machine, and we would advise that you select a machine based on the suggestions in that module's README. Since you want to align the compute with the processes you'll be running in the module, and having more compute will cost you more, but won't necessarily give you better performance. We'll stick with the default here, but you can go through, select different series, and then select within those series different machine types to give you more cores and more RAM. The other important consideration is the enable idle shutdown. We recommend 60 to 180 minutes, and this ensures that if the machine is running and active but idle, it will shut down after the defined time, saving you some money and making sure that your billing stays low if the machine is not in use and you forget to turn it off after you're done with it. The other option to take a look at is the disks option to show how much space you want to allocate or provision to your virtual machine. The default options of 150 and 100 gigs for most of the modules will be sufficient. And again, if additional disk size is needed, that should be outlined in the README, but we'll keep the default. And then for networking, IAM security, and system health, you can look at these in more detail. However, the default selections should suffice. Once we go through all of these options, we can click Create and start provisioning our virtual machine. When you do this, you'll be brought back to the Workbench menu, and you'll see the instance that we just created is now in pending status, indicated by the circling status icon. However, I've previously created an instance that is currently active, as denoted by the green check mark. We will go into this instance and start running Jupyter Lab by clicking on Open Jupyter Lab. This will open a new window with Jupyter Lab in it, where we can look at our directory and start to clone in our public GitHub repository. To show you what this looks like, we have the structural biology and drug discovery public repository, which we're going to clone into Jupyter Lab for demonstration purposes. I recommend going to code and using HTTPS, cloning this URL, and then using this URL, we will use the git clone command to clone in the repo to our Jupyter Lab. When Jupyter Lab opens, it should bring you to the launcher page. We'll open up a terminal window. And just for illustration purposes, we'll print the working directory. You see we're in the directory, and then type ls to list the files and folders in our current directory, and we see it's in the directory that we see here on the left-hand side. This just ensures that we're in the directory that we want to clone our GitHub repo into. And once we've confirmed that, we can type the command git clone and then paste in the previously copied HTTPS URL. This will start cloning in the repository, show the status updates, and then it should show up as a folder on the left-hand side. We can then click in this and navigate the repository and go through the various submodules to continue our learning journey. That's all I have today. Thank you so much. Good luck.